Let's go to the example 1. In this example, what we do is we are going to calculate the surface area of the portion of the plane 2x plus y plus a equals to 2 that lies in the first octant. The first octant is the part where all x, y and z coordinates are greater than or equals to 0. Okay, so the first thing we should do is to draw this plane. Okay, let's draw the x, y and z axis. X, y and z axis, and then let's draw the plane 2x plus y plus z equals 2. The plane is 2x plus y plus z equals to 2. Okay, to draw this plane, first identify x, y and z intercepts. As an example, to get the x intercept, substitute y equals 0 and z equals 0. Okay, to get the x intercept, substitute y equals 0 and z equals 0. Then you will get 2x equals to 2, therefore x equals to 1. Okay, so that's the x intercept. And to get the y intercept, substitute x equals 0 and z equals 0. This means y equals to 2. Similarly, you can calculate the z intercept, and z intercept equals to 2 as well. Okay, so this. Okay, now our plane in the first octant should be something like this. Okay, now in this problem, what we do is we are going to calculate the surface area of this part, this surface. This is your surface S, which is given by 2x plus y plus z equals to 2. Okay, now how do we calculate the surface area? Okay, surface area equals to double integral of square root of 1 plus partial f of partial x squared plus partial f of partial y squared dA over the domain D. Now this domain D is on the xy plane, and dA is an area element on the xy plane. Okay. Now in this problem, we need to figure out this function f. To do that, let's solve this equation for c. Since 2x plus y plus z equals to 2, the c value equals to 2 minus 2x minus y. Now this is your little f of x comma y. Okay, let's calculate partial f of partial x and partial f of partial y. Derivative of f with respect to the x variable equals to negative 2. Partial f of partial y equals to negative 1. Okay. Now let's substitute these two values into the formula. So now we have surface area equals to square root of 1 plus negative 2 squared plus negative 1 squared dA over the domain D. If you simplify the integrand, you will get negative 2 squared is 4, 4 plus 1 is 5, negative 1 squared is 1, 5 plus 1 is 6. So we have our integrand equals to root 6 dA. Now we need to figure out this domain D. Okay. Let's go back to the figure. This domain D is on the XY plane. The domain D is on the XY plane, and it should be this portion. That should be your domain D. Okay. It's a projection. So let's consider the XY plane. So this is the x-axis, this is the y-axis, and now we have a line. So basically this line is over here, and our domain D is this one. Okay, so let's find the equation of this line, this one. Okay, to get the equation of this line, what you need to do is you need to substitute c equals 0, and the reason is this line is on the xy plane, and on the xy plane your c coordinate equals to 0. Therefore this line should be 2x plus y equals to 2. Now if you want, you can solve for y, then y equals to 2 minus 2x. What is this? This x-intercept is 1, so it should be 1. Y-intercept should be 2. Okay. At the moment we have our surface area equals to double integral of root 6 dA over the domain D. Okay, now let's express dA. dA is an area element on the xy plane, and we know that dA equals to dy dx or dx dy. But in this one I am going to consider the first double integral, but if you want, you could even consider the second double integral. The only difference is this order of integration. So here my order of integration is dy dx, but in the second option my order of integration is dx dy. If I consider the first option, now we need to find these four limits. Okay, now we know that the outer integral must contains the constants. Okay, now if you go back to this xy plane, we know that x goes from 0 to 1. Okay, therefore the limits of the outer integral are 0 and 1. Okay, now let's figure out the limits of the inner integral. Inner integral corresponds to the y variable, and y goes from, if you think about this area element, the lower limit of y is bounded by the x-axis, and the upper limit of y is bounded by this line. The lower limit of y should be 0. However, the upper limit of y should be 2 minus 2x. Okay, let's integrate this. Root 6 is a constant, and we can pull out a constant from the integral sign. Okay, 6. If you integrate 1 with respect to the y variable, you should get y. The lower limit is 0, upper limit is 2 minus 2x dx. Okay. Apply the upper limit and the lower limit. Upper limit will give you 2 minus 2x minus the lower limit is 0 dx. Okay, let's integrate this. Now our variable of integration is x. Okay, integrate 2, you should get 2x minus 2 times integral of x is x squared over 2. Lower limit is 0, upper limit is 1. Now here you can cancel this 2 with this one. Apply the upper limit. You will get root 6 times 2 minus 1 minus, if you apply the lower limit, you should get 0 minus 0. Okay, 2 minus 1 is 1. 1 times root 6 is root 6. This is the